Okay. The mechanism of elimination, طلبة. He said here, what is the mechanism of elimination? Elimination meaning حذف. What is the order, okay, of bond breaking out and bond making? You have there is some bond to be broken out, and there is some bond to be formed. And this reaction, one step, a process. Look, one step, a process here. One step, a process. That meaning elimination. This elimination, it will be one step or maybe two steps. Okay, doesn't occur in many steps. It will be happen many steps or just one step. He said that. Okay, here there are two mechanisms. It is like substitution. There are two mechanisms for substitution, SN1 or SN2. The same thing here. We have elimination 2 and elimination 1. And there are different between of them. The like SN2, E2 mechanism is bimolecular elimination. Okay, bimolecular again. What meaning bimolecular? That meaning the kinetic, the rate of reaction depended on the concentration of the substrate, the alkyl halide, the static material, also the concentration of the base. Okay, both of them can be effect for the speed of reaction, can be effect of the reaction. Okay, the E1 is unimolecular elimination. Okay, E1, it is like SN1. That meaning the concentration of the base or the concentration of the base cannot be effect for the speed of reaction, for the rate of reaction. Okay, that meaning just the alkyl halide, it will be appear in the rate equation. Okay, here the rate equation. That meaning just the concentration of the static material can be effect of the rate of reaction. Okay, and we said this, if we talk about the rate, this is, it will be fast, this is slow. That meaning we talk about kinetic الحركية. Okay, and E2 reaction is have a second order kinetic. We saw that. That meaning the reaction is bimolecular, and both the alkyl halide, look, both أو مهمة أو كلمة, both alkyl halide and the base, both of them can be effect of the rate of the reaction, can be appear, it will be appear in the rate of the equation, this equation أو معادلة. Okay, هردك للتأثيرتين. Now, he said, and the most straightforward explanation for the second order kinetic is the concentrated reaction. All bonds are broken. Look, this is the A1. It is like SN1, just one step mechanism. That meaning all the bonds are broken and formed in the single step. Look, this here, it will be attack the proton. That meaning we have a new bond here. This hydrogen carbon bond, it will be open and it will be added to here. That means this bond, it will be broken. This bond between carbon, okay, here the double bond, it will be formed. We have, it will be double bond. This bond between carbon and the halogen, it will be broken. Okay, all of them in one step. All of them in one step. And you look here, the base, remove proton from the beta carbon. Look, the base remove the proton from the beta, not the alpha, because we need double bond between alpha and beta carbon. That meaning we need to remove this proton, not this. Okay, this also beta, the same thing. Yeah, that meaning if you have a proton here in this carbon, for example here, hydrogen. Okay, if the base remove this hydrogen, there is nothing, it will be happen. Okay. That meaning from the beta, this halogen, this alpha carbon, and this beta carbon, the base will be removed the proton. Why we said here proton? Look, proton. Why we don't say hydrogen? Because it's partially positive. Okay, partially positive. That meaning acidic hydrogen. Acidic hydrogen meaning a proton. Okay. Okay. We say the proton here. That meaning this proton meaning acidic hydrogen. Hydrogen partially positive. Because this is high electronegativity atom, it will be it will be withdraw all the density from this bond. That means this partially positive, this partially positive, this partially positive. Okay, this it will be acidic from the beta carbon forming H2O. طبعا leaving group it is stable as side product. We have a water as side product. Now, the electron pair in the beta, look, in the beta carbon hydrogen bond, this here, okay, form a new pi bond. This hardo electron, but both of the electrons will be converted to here to make a new double bond, and it will be double bond. Okay. The leaving group here, it will be go out. It will be removed from structure with electron pair. That meaning the both of the electron here, it will be removed with the leaving group. Okay, it will be go out with the leaving group. And look, if you have like this, use curve arrow. That meaning he said, طبعا we know this curve arrow, we talk about this. He said here, use curve arrow to show movement of electron for the following mechanism. That meaning how the mechanism will be happened here. Okay, like this. I want like this. Okay, try to make the mechanism of this reaction to give you this product. Okay, and he said, why this inert to E2 elimination? That meaning why this compound cannot be entered to the elimination reaction. There is no elimination reaction for this compound. Why? Okay, think why this is good question. Okay, this is good question, and try to resolve this question. That is homework for you. And he said in the transition state, we have a transition state. Transition state meaning حالة انتقالية. Okay, not compound, just intermediate. Also, it is like intermediate product. Okay, you cannot separate this compound. Just transition state, حالة انتقالية. The carbon, hydrogen, and carbon Br bond are partial broken. That meaning this bond and this bond, it will be partially broken. And the O hydrogen here, oxygen hydrogen bond, are partially formed. Yes, we have, it will be formed here. And both the base and here, the base, okay, this is the base and the departing leaving group pair in the partial negative charge. That meaning, this is the base and the leaving group, it will be partially negative. Okay, that meaning all this is partially positive. This partially positive, this partially positive, and this partially positive. Okay, and here said, if you have this reaction, you need to go to the transition state. The energy, that meaning this reaction need energy, and it will be give you the product. Okay, that meaning you need this energy to pass this curve, to pass this top of the curve. Okay, to pass this top of the curve. That meaning you need this energy. Okay, an energy diagram for the reaction. This reaction is shown in this figure here. The reaction has one step. Look, just one step. There is no step. And two bonds are broken. Yes, we know that. And two bonds are formed in single step. This is just one step. So the transition state contains 4 partial bonds. Okay, that means this partial bond, this partial bond, this partial bond, and this partial bond. Okay, look, it is like a dot, 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 dot. That meaning we have 4 bonds. 2 a new bond and 2 bonds, it will be broken out. Okay. With the negative charge distribute over the base of the leaving group. Okay, the negative charge, where is the negative charge? Over the base and the leaving group. That meaning we have negative charge here, partially negative, and we have partially negative here. Okay, And the entropy favor for the product of the reaction because the two molecules of the starting material form three molecular product. Okay, that meaning this we have two, and it will be give you three product. Okay, that meaning the entropy طبعا عشوائية أو entropy it is not our work now, but it will be it is favor from the starting material to the product. And the base. The base appears in the rate of equation. That meaning the base can be effect for the rate of reaction. If you have strong base, your reaction will be speed, it will be fast. If you have weak base, the reaction will be slow. Okay, that meaning the base of it will be effect of the rate of the reaction. So the rate of the E2 reaction increase as the strength of the base increase. Okay, the leaving group also, because the bond to the leaving group is partially broken in the transition state. Okay, transition state, the better leaving group is the faster of the E2 reaction. Yes, better leaving group, your reaction, it will be faster. It will be easy. It will be easier. Okay, that meaning increased leaving group ability. Okay, an increased rate of reaction. That meaning iodo-alkyl halide is the enter to the E2 elimination faster than the bromo-alkyl halide, and the bromo faster than the chloro-alkyl halide, and the chloro-alkyl halide faster than the fluoro-alkyl halide. Okay, why? Because the ability to the leave of the from the structure, the ability of the leaving group. Okay, anyone is best leaving group, anyone good leaving group. Okay, that meaning I minus good leaving group. If you compare I minus with the chlor, no, I minus it will be better leaving group than chlor minus. Why? Because I minus more stable. We know the size of the iodine is big and the size of the chlorine is small. That meaning if you have negative charge distribute on the big size, it will be more stable. Okay, then he said here, the identity of the alkyl halide. Now we know the base and the leaving group. Now what about the starting material? How the starting material can be effect of the rate of the reaction or the E2 elimination reaction. Okay, he said here the SN2, look, he said the SN2 and the E2 mechanism differ in how the R group effect of the reaction rate. Now, if you remember about the SN2, if you remember what we said, more substituted alkyl halide, okay, that meaning it will be better or not better for the E2 for the SN2 reaction. Okay, it will be not better. Why? Because the more R group, it will be so that's your starting material, it will be so crowded. That meaning the steric effect it will be high. That meaning for the SN2 reaction it will be not good. Okay, that means if you have alkyl halide, tertiary alkyl halide cannot be entered to SN2 reaction. It will be SN1. Okay, why? Because the steric effect here differ. Okay, reverse. More R group substitute on the carbon of the leaving group, it will be better for the E2 mechanism. Okay, that meaning E2 is reverse to the SN2, not like each other. Okay, about the starting material, about what? About the alkyl halide. That meaning tertiary alkyl halide, it will be good for the E2, but not good for the SN2. Primary alkyl halide, it will be good for the SN2, but not good for the E2 elimination. Okay, now he said here, as the number of R group on the carbon with the leaving group. Look, on the carbon with the leaving group, okay? The group increase, the rate of the E2 reaction increase, okay? Be careful of R group on the carbon of the leaving group. Okay, that meaning we have halogen, carbon, the R group on this carbon. Okay, I will give you example. Look here. Look, this carbon of the leaving group, we have 3 R groups, 3 alkyl groups on this carbon, and here we have just one R group on this carbon. The carbon bonded directly to the leaving group. Okay. Now, if you remember, for the SN2 reaction, anyone is based this or this. Of course, this it will be based and faster. Okay. Why? Because less steric effect. The nucleophile can be attacked from the backside, if you remember that. Okay. And the tertiary cannot be entered to the SN2 reaction. But here in the elimination reaction, in the E2 mechanism, no. The tertiary alkyl halide is the
Saidio dan Nina.
okay. Now, okay. Now, again, he said here for the E2 reaction, again, for the E2 reaction, the more substitute alkyl halide, it will be faster than the primary alkyl halide. And he said here, why here does increasing alkyl substitution increase the rate of the E2 reaction? This is a good question. Okay. طبعا, of course, depended on the stability of the transition state here. Okay. We said, look, Talaba, we said we have partially negative, and here we have partially positive, partially positive, partially positive. Okay. That meaning more R group here donating electrons density for the partially positive, it will be more stable. Less alkyl group here, that meaning it will be not stable, or the stability it will be decrease. Okay. Now, and he said here, in the transition state, the double bond is partially formed. That meaning we have double bond here. Okay. So, in increasing the stability of the double bond, that meaning if you have alkyl group here, donate electron density, okay, like alkyl substitute stabilize the transition, that meaning your transition state, it will be more stable, okay, which increase the rate of the reaction. Now, I have here, okay, and he said here, increasing the number of R group on the carbon with the leaving group. This is the leaving group, this is the carbon. That meaning the carbon here increase the R group on the carbon of the leaving group, form more highly substituted what? Alkene, more stable alkene, okay? More highly substituted alkene, more stable alkene in the E2 reaction. Okay, and he said here, I hope you understand this. I hope that also easy, but just think about the transition state, okay? About the stability of the transition state. Now, he said here, for example, if you have this reaction, look, this 1-bromobutane and this 2-methyl-propan. Look, this is the alkyl halide. This leaving group bonded to the carbon. This carbon we have 3 alkyl group. But this halogen bonded to the carbon just has 1 alkyl group. Okay. Anyone, it will be faster for the E2 reaction. Of course, this it will be faster for the E2 reaction. Why? Because the stability of the transition state. Okay, because the stability of the transition state and the stability of the new double bond. This is the new double bond. Okay, the new double bond. Okay, now look to the difference. If you, this compound, 1-bromobutane, it will be entered to the E2 reaction. Where is the alpha carbon? This alpha carbon. Where is the beta carbon? This beta carbon. Okay, that meaning we have proton here and the proton here. Okay, one of them. The base, it will be attack this proton. Make for you a new bond here. This is the new bond. Okay, and this alkene is di-substituted, mono-substituted, or tri-substituted? Of course, is mono-substituted. That meaning the double bond, we have just one alkyl group, mono-substituted. Okay, anyone is based mono-substituted or di-substituted alkene? Anyone is more stable? That meaning the the di-substituted alkene is more stable. That meaning this is the best. Okay, this is the easy reaction. This is the easy or the faster reaction. You can say the faster reaction. Okay. And he said here anyway.
ستيبل بس هنگی منت گوته که دبل بوند بیت یعنی گیما ستیبل
تمام
هگه دبل بوند بیت يعني ستيبلتي ويا جيما
يا دبل بوند stability وكيما
اي بسيدة فيران صوتويت بها هگه دبل بوند بيتو ستيبل
ما أنا هاردو دبل بوند كش مور ستيبل أوا
يا بني بيتر أورد بيبا أو
بيتر آر يعني مور ستيبل هاردو ضعيف درسته بس كش باشترى أو باشترى
يدرس
معناه يعني مثلا أنا بيجن أو هاردو طلبة مثلا نازرة بس كش قلق نازرة كأبا مثلا okay the same thing here. Yes, the double bond, we said it is weak bond, it is active bond, not stable, but anyone is more stable. If you compare this double bond with this double bond, of course, this, it will be more stable. Why? Because more substituted, more alkyl group. Okay. Okay, thank you for your question. And also you have homework here, rank the alkyl halide here. All of this is alkyl halide. In each group in order, look, increasing reactivity to the E2. Anyone is the best for the E2 reaction. This or this or this. Anyone, it will be the first, the easier one, the faster one. Okay, anyone, it will be the faster one. And also this or this or this. Look, this is primary, this secondary, this tertiary. Okay, also this tertiary, and this is primary, and this secondary. Okay, and rank, put it in the according to the increasing the stability, or anyone, it will be the faster one, the faster, and then the slowly and the more slowly. Okay, this for you, easy, also easy, not so. And he said the Zaitsev rule. What meaning the Zaitsev rule? He said we have rule here. If you have more than one beta carbon, okay, look to this reaction. Okay, this alkyl halide, yes, we have alkyl halide, but we have this carbon is alpha, as beta carbon, this alpha, this beta carbon, also this beta carbon, but this beta different from this. Okay, different from this. That meaning we have two products. If you, the base, remove this proton on this beta carbon, okay, give you this product. If the base remove this proton here, give you this product. Anyone is the best. Anyone is the major one. Anyone is the minor one, okay? Now we have rule here, the Zaitsev rule. He said the major product for the more stable product, look, is the more stable. Anyone is more stable, this or this. How we know? We said, of course, we said the Tri substitute more than stable more than di substitute stable more than mono substitute. Now, look to this alkene. This alkene, we have how many R group we have here? We have one. Also, we have carbon from here. Also, we have carbon from here. That means this tri-substituted. Look, tri-substituted alkene. But this alkene here, on this side, okay, we have just this hydrogen. But this have carbon. This di-substituted. Anyone is more stable? Of course, the more R groups, it will be give you more stable alkene. That means this is the major one, the more stable one. Okay, anyone is more stable, the one with more substituted double bond. Okay, the more substituted double bond. For this reason, this compound yield two constitutional isomers. This compound give you two product. This one is more stable than this. Now here, the major product again, and beta elimination. We said why we said beta elimination? Because we have elimination, it will be happened on alpha and beta carbon. It will be said beta elimination. Some books write 1-2 elimination. Okay, 1-2 elimination, but here he said beta elimination has more substituted double bond. Look to this reaction. How many different beta carbon we have here in this compound? We have two different beta carbon. This like this B1, and this is different. It will be B2. That meaning we have two product. If you remove this proton or this proton, give you this product. If you remove this proton, give you this product. This di-substituted, look, one alkyl. This try 1, 2, 3. Anyone is the major one? This is the major one. Okay, this the major one. Why this is the major one? Because more stable for the double bond. Why more stable for the double bond? We say because the stability of the transition state of the reaction. Okay. Now having we said here D, we said it is more stable than B because we have 3 alkyl groups. It will be the major one. Okay. And he said here, if you have like this compound, okay, and it will be give you the double bond. Of course, we said before that all the trans alkene, it will be stable more than the cis alkene. That meaning when a mixture of stereoisomers is possible, please move this window anyway. Okay, I don't know. Okay, from the dehydrohalogenation, the major product is the more stable stereoisomers. Okay, stereoisomers, we have cis with trans. Okay, a trans all the time, it will be more stable than the cis. That meaning the trans is the major one, the cis is the minor one. Look to the here, you have base. Okay, this strong base. The strong base attack this proton, remove it and make the double bond here and give you product. Product, we have isomers, cis with trans. Anyone is the major one? Of course, the trans is the major one. Okay. Now, he said predict the major product of the following E2 reaction. You have this E2 reaction. That meaning elimination reaction. Okay, where's the leaving group? This is the leaving group. Where is the beta carbon? This alpha carbon. We have beta here and we have beta here. Okay, that meaning also we have two probability for the products. Okay, يعني دو احتمال بناتجها. Okay, the first one, if you remove this proton, okay, and it will be give you this. And the second one, if you remove this proton from here, and it will be give you this. Anyone is the major one. Look, anyone is more substituted double bond. Of course, this more substituted double bond, and it will be the major one because this tri we have alkyl here, and carbon here, alkyl. Okay, 3 alkyl group. It will be the major product, and here just we have 2 carbon, 2 alkyl group. It will be the minor one. Okay, and
سيدة بس جبتها جود بابا.
دنجة منتيا
Ne bes mugay kita good bova vaberinuki.
ايش ابا
Sida bucho ay.
اي more substituted alkene. Look, this double bond كم كربون double bond هيا this egg do say okay say carbon يعني try substituted. But this double bond, look to this double bond. How many carbon we have for this double bond? We have just carbon, this and this carbon. That meaning two alkyl group, two R group, di substituted. Anyone is more stable, we say try substituted double bond. It will be more stable than the di substituted alkene. Okay. We take it this. Oh. And this about the mechanism A2. Now this homework for you. What is the alkene are formed from each alkyl halide by E2 reaction. That meaning this it will be entered to the E2 reaction. Okay. طبعا according to what? According to the Zaitsev rule, to the measure and minor product. Okay. إذا هكا دو احتمال هيا سي احتمال هيا بوناتج همين بنبيسا وكش one is it will be the measure one, any one it will be the minor product. Okay, and he said it is like we have SN2 SN1, also we have here E2 E1, the E1 mechanism. Okay, the E1 mechanism again. The E1 mechanism, if you have this alkyl halide, okay, that meaning the dehydrohalogenation. We say dehydrohalogenation, I remove hydrogen and halogen from the structure for this, with the H2O forming this compound, can be used to illustrate the second general mechanism for the elimination. We can use any mechanism for this compound, okay? Now, we say by E1 mechanism. What meaning E1 mechanism? How it will be happen for any time? It will be happen the E1 mechanism. We will take it and we will be explain for you all these factors. Now, the kinetic for the E1 mechanism, it is having just first order kinetic. Okay, that meaning just the concentration of the substrate, that meaning the starting material, it will be appear in the equation for the rate of reaction. Okay, and that meaning the concentration of the nucleophile H2O, like this H2O, if you have more concentration of the H2O, cannot be effect for the rate of reaction. Okay, now this it will be the different from the E2 and E1. We said E2 the concentration hard to get for the starting material or for the base, for the rate equation. But here in the E1 mechanism, no, just the concentration of the substrate, it will be appear. Look, just the concentration of the substrate. There is no concentration for the H2O. Okay, that meaning it is like SN1 mechanism. Okay, the kinetic suggests that the reaction mechanism involve more than one step. Okay, also that is like SN1 mechanism. E2 mechanism طلبت just one step like SN2, but E1 mechanism okay, but the E1 mechanism it is like SN1, we have two steps for the reaction. Okay, and we will take it. Look to the step of the mechanism. We have 1, 2. The step number 1, look to the step number 1. Also, we have carbocation like SN1. Okay, that meaning E1 like SN1. We have also carbocation. Okay, we have also carbocation. The second one, look to the nucleophile attack the alpha proton, the beta carbon, to make a new bond here and give you the protein. That meaning is easy, actually is easy mechanism, not so difficult. Then he said the most startful explanation for the observed first order kinetic is the two-step reaction. That meaning we have two steps. The bond, look, the bond to the leaving group breaks first before the pi bond is formed. That meaning we have this bond between the leaving group and the carbon. It will be broken firstly, okay, يعولي. And then this bond here for the base and the proton, it will be formed, or and then the pi bond, it will be formed. Okay, here the difference. And look to the first step, heterolysis of the carbon iodine bond forms an intermediate carbocation. That meaning heterolysis. What meaning heterolysis? That meaning hard dual electron, it will be removed, it will be go with the iodine. That meaning the breaking, it will be not homolysis. Hard dual electron, it will be removed with the leaving group and give you carbocation. Okay, and give you carbocation. This carbocation طلب stable? Yes, stable. Why stable? Because tertiary carbocation. Okay, this is tertiary carbocation. Okay, all these R groups donate electron density for the positive charge and make it slightly stable. Now, the second one, the base, here the base, the H2O, remove a proton from the carbon, adjust to the alpha carbon. That meaning this base remove the proton, okay, from the beta carbon. This is the beta carbon. Look, from the beta carbon, okay, and the electron pair, hard dual electron, it will be make a new bond here. Okay, hard dual electron here, it will be make a new bond to give you the product. Now, in an E1 reaction, the leaving group come off before. Look, that meaning the leaving group, it will be leave the structure firstly. Okay, but here no, the leaving group with the base, both of them in the same time. That meaning this is two-step mechanism. This is just one-step mechanism. Okay. Also, I said before that is not so difficult, easy mechanism. And look to here, we have this starting material. Look, this is the transition step 1. Okay, transition step 1. The halogen, it will be, or the leaving group, it will be go out and give you this carbocation. This the carbocation, and then the base, it will be attack the beta proton, and give you this the second transition state, and finally give you the product. Okay. طبعا طلب this curve just to explanation how the steps it will be happened in the reaction. يعني all this طلب just one step. But here it is the curve energy. Okay, the curve energy, just for understanding this, just for understanding how it will be happen. That meaning you have two transition state, this transition state and also this transition state. Okay, also you have here positive charge, we said before that, that meaning also we have more R group, it will be make for you this transition state more stable. And he said the E1 mechanism has two steps. Yes, there are two energy barriers. Yes, we have two energy here. Step 1 is the rate determination. Okay, not so important, just for understanding. Other characteristic of the E1 reaction. Okay, other characteristics يعني خواص أخرى for the E1 reaction. 3 other factors. That meaning we have factor here, okay, any factor here for the can be effect for the E1 reaction, okay. Number 1, the rate of the E1 reaction increase as the number R group of the carbon with the leaving group increase, okay. Look here, this is a primary alkyl halide, this secondary alkyl halide, this tertiary alkyl halide. That meaning increase the rate of reaction. Why? Depended on the stability of the carbocation. Increase the stability of the carbocation. This give you this carbocation, tertiary carbocation. Secondary alkyl halide give you secondary carbocation. Primary alkyl halide give you primary alkyl carbocation. That meaning more stable carbocation, it will be faster for the reaction and it will be easy to give you the product. Okay. This is the first one about the alkyl group. The second one, because the base, look, because the base doesn't appear in the rate of reaction, يعني that the concentration of the base cannot be effect for the rate of reaction. Weak base, look طلبة, weak base favor for the E1 reaction. That meaning all the times E1 it will be used weak base, not strong base. Okay, strong base for the E2 reaction. Okay, strong base for the E2 reaction, but the weak base is the best for the E1 reaction. Okay, this is the difference. And the strength of the base usually determine whether the reaction, look, if it will be E1 and the E2. That meaning if you have reaction and I put it for you strong base, and I say to you any elimination directly, if you look to the base and you found the base is strong, directly that meaning it will be E2 reaction directly. And if you look to your base like water, كحول, weak base, directly your reaction it will be happened by E1 reaction. Very easy. Just look to the base. Strong base E2, weak base it will be E1 reaction. Look here, strong base like this, OH minus or minus, it will be this strong base for the A2 reaction. But like this H2O or كحول, it will be for E1 elimination. Very easy. Not also you cannot need to think. Just look to the base and look. This is starting material. This is starting material, and this is a product. Okay, that meaning we have double bond. That meaning this reaction is elimination. Look to the base here, strong or weak. This weak base. That meaning this it will be E1 or E2. Of course, it will be E1. Okay, it will be E1 reaction, elimination one. Okay, anyone is the major one, this or this? Of course this. Why? Because this is tri-substitute and this di-substitute. And finish, okay? There is nothing else. Here, the scent and the E1 reaction are rego-selective, okay, like E2 reaction. That meaning all the times the major product it will be more substituted. Okay, all the times the major one it will be more substituted alkene. يعني it is like زيت الفرول. Okay, dependent on the stability of the carbocation. Okay, like E2, the same thing. يعني طلبة E1 it is the same for the E2, but the mechanism different. E2 one step, E1 two step. The base for the E2 strong base, and the base for the E1 is weak base. And he said here, this homework for you, what alkene are formed for the each alkyl halide. Look, this alkyl halide, this alkyl halide. By chia, by E1 reaction. Okay? And they use the zeta rule to predict the major product. Okay? Write the product. That meaning we have more than one product. We have two products. Okay? Or maybe three. And anyone, it will be the major product. Anyone, it will be the minor one. This for anyone for this? Yeah, sorry. You have a major one, have a minor one. Both you have a major, two major. Ciao, or double bond. Look to the double bond. This double bond. Chant R group sir, this double bond. Chant have a carbon egg. This one have a number egg. With this carbon do. With this carbon C. يعني C carbon صار this double bond هيا. Okay. Look to this double bond. This hydrogen حسب لك not alkyl group, not carbon. This carbon and this carbon يعني have a do group و have a C group. كش more stable? C group. More substituted. Okay. كان alkyl group قلق هيا يعني it will be major one. It will be more stable. Okay. دقشتي؟
درست أسئلة.
Okay. Also, I explained this for the last lecture, not this lecture. Okay, you can go again to see the last lecture. I explained this. It will be mono, di, tri, substituted alkene. Okay, easy, very easy.
هيدا بس بسيارة بابا بني ما ندي ويك بيسك إينا
This?
أبو دي H2O
any base, weak base. H2O, كحولة، تشنكو أو جوتيفيري E1. هكا بنفيسا weak base. دعيناك تبيجا H2O كحولة. أي تشت. اوكي بس المهم برودكت من البيت برودكت شيء. اوكي look here the difference between SN1 and E1 reaction. Okay, SN1 and E1 reaction have exactly the same first state formation. يعني شيء يعني هردوكا خطوة أولي carbocation هي. Okay, carbocation it will be formed carb cation. It will be formed. Okay, the same thing. They differ in what happened to the carbocation. Okay, they differ in what happened to the carbocation. Okay, now what will be happen for the carbocation? Look, the SN1, the nucleophile attack the positive carbon, but the E1, the nucleophile attack the beta hydrogen, not attack the positive carbon. Okay, here the difference. That meaning SN1 give you substituent يعني تعويضة يعني تبديل صار this carbon, but B2 elimination give you حذفة elimination. Okay, this is the difference. يعني step if you go to the mechanism for the SN1, step 1 for the SN1 and E1 the same step. Both of them give you carbocation, but for the SN1 the nucleophile it will be attack the carbocation, but for the A1 no. The base or the nucleophile it will be attack what? It will be attack the beta hydrogen on the beta carbon and give you new double bond here. This the different. Okay, and he said here SN1 reaction nucleophile attack the carbocation forming substitution product يعني مركب معوض. But for the E1 reaction, no. The base remove the proton to form what? To form a new bond, to make a new bond here. Here the different. And he said, look to this equation. Draw the SN1 and E1 product formed in the reaction of this with H2O. Okay? You have this alkyl halide. Okay, give me the elimination and the SN1 يعني substitution product. Okay. Harduka carbocation formation. Okay. Step number 1, remove the leaving group, give you carbocation. Okay. Step number 2, look. This the nucleophile attack the carbocation. Okay. Give you this product. And then remove the positive charge, give you كحول. Okay. SN1 product. يعني have a substituted product. But this, no. This it will be attack the beta halogen. This is the beta halogen, okay, on the beta carbon to give you a new product. That meaning this E2 product. That meaning elimination product, and this is substitution product. Okay, this is the difference. We say the difference between the SN1 and the E1 mechanism is how the nucleophile here attack the carbocation, but the nucleophile here no attack the alpha, the beta hydrogen. Okay. This also the same homework. Draw both the SN1 and E1 product for each reaction. Okay, this and this. Okay, do reaction here. بنبي هردوكا the E1 product or the SN1 product. Okay. وهكذا more than one product هي هم بنبي بيجي a major one and a minor one. Okay. And he say when is the mechanism E1 and E2? Okay, anytime E1 it will be happened, anytime E2 it will be happened. We said before that dependent on the base strength. Okay, القاعدة أو nucleophile. A strong base, also we said and weak base. And he said how we whether know it will be 1 or E2, because the rate of the both of the E1 and E2 reaction increase as a number of R group on the carbon with the leaving increase. Here we cannot identify the alkyl halide to decide which elimination will be happen. يعني if I give you this طلبة, for example, I give you this alkyl halide and say to you anyone it will be happened E1 or E2. هكا تصحكي alkyl halide تنشد بيجا E1 و E2. بوشي چونكو هردو كان بيجا more substituted alkyl halide it will be best for the E1 E2 بوهردوكا. Why? Because here more substituted alkyl halide for the E2 give you more stable for the alkene, more stable for the transition state. And for the E1 mechanism, no. More substituted alkyl halide give you more stable carbocation. That meaning cannot be enough. If I give you the structure for the substrate, cannot be enough to know it will be E1 or E2. چونكو هردوكا the same. More يعني tertiary طلبة tertiary alkyl halide it will be best for the E1 E2 بوهردوكا. وبرايمري alkyl halide بوهردوكا ناخوشة. Okay? This. And he said cannot be enough to identify the alkyl halide to decide anyone it will be the best. That meaning we go to the what? We go to the base. Okay, he said here the strength of the base is the most important factor to determine the mechanism for the elimination. Okay, the strength of the base. أوقالك مهمة طلبة. Okay, that meaning if we use strong base, that meaning it will be E2 mechanism. If we use weak base, it will be E1 mechanism. Okay? And okay, مقارنة E2 much more common and useful. E2 here much less useful because mixture of the SN1 or E1 product usually result. Why? Look, for the E2 mechanism طلبة give you one product. Okay, there is no probability to happen SN2. Okay, E2 if you have elimination E2 cannot be happened SN2 at the same time, but E1 maybe the same times it will be SN1 also. That meaning here it will be give you mixture, but here it will be give you just one product or less than two product. Here the favored by strong. Look, the E2 it will be best for the strong or negatively charged base. Negatively, يعني full negative charge. Okay, like what? Like minus OH minus OR. Here no, favored by weaker base. Okay, or neutral base like H2O, like alcohol. E2 mechanism طلبة the reaction occur with primary, secondary, and tertiary alkyl halide. Okay, Buhar say it will be happened E2 mechanism, but anyone is the best. The tertiary is the best, and then the secondary, and then the primary. Okay, E1 mechanism, the mechanism doesn't occur with a primary alkyl halide. That meaning if you have primary alkyl halide, there is no E1 mechanism. Why? Dependent on the stability of the carbocation. You know the primary carbocation not stable. Okay, not stable cannot be happened. Okay, why? Because they formed highly unstable. Look, unstable primary carbocation. This the difference between E2 and E1 mechanism. Do you understand this? I think you understand this. The stability of the carbocation. يعني here. Okay, like this. Okay, carbocation. If you have mono primary carbocation not stable. That meaning not stable and cannot be formed for this reaction. Anyone? Here. Okay, for this step, for the E1 mechanism. If you have primary carbocation here, just one alkyl group, it will be not stable. Not stable يعني أو خطوة نينة. أو خطوة نينة يعني E1 نينة. Okay. Okay. And he said here, which mechanism E1 or E2 will occur in each reaction. Okay. This, it will be E1 or E2. Okay, look to the base. This strong base, يعني E2. Okay, this a neutral
E1.
base, weak E1. خلاص. This a neutral base E1. This strong base E2. Okay, easy, yes? Okay. Also, طلبة, if you use here weak base, if you use weak base, there is no look for this reaction D طلبة. For reaction D, if I use H2O, any mechanism?
E1.
نا E1.
هكا جيبي ببقى H2.
ايه H2O هكا جهي أفا. ها أفراكا و H2 دانا أو كحول دانا ميثانول. دبنا كش ميكانيزم؟ E2 تشيد بيت E2؟
هكا بس جي و إيه أوي.
هكا بس
وإيسينا
جي
بينا بقى H2.
هكا بس جهي أفا. بس جهي أفا كحولة CH3 OH وكي أفا. أفا دانا فيري. أو reaction كش ميكانيزم؟ E2 تشيد بيت E2؟ E2 can be happened? No, yes. Okay. Look, if you put the methanol here or the ethanol or the water, E2 cannot be happened. Why? Because weak base, we know that. E1 can be happen, also E1 cannot be happen. Why? Because here the alkyl halide give you primary carbocation not stable. يعني أفانا هكا تفيري بس أفراكا دانا ميثانول or H2O هارتو كتشنابت نا E1 نا E2. Okay? نا E1 نا E2. Okay, just for more understanding. Repeat again and look to the lecture again. Okay, now. Here, dehydration, look, طلبة, dehydration of alcohol. What meaning dehydration? Dehydration يعني يعني H2O molecule, hydrate molecule, remove. Okay? That meaning remove the OH and the H2. يعني remove the H2O group. H2O group. Remove the water molecule. Okay. Now, you have كحول. Look, طلبة, you have كحول and this alpha carbon and this beta carbon. And you have here hydroxyl OH group and this hydrogen. Remove this and this. It will be removed like H2O and you have double bond here. Okay. This also elimination reaction. And we say dehydration. Dehydration. يعني remove H2O group from the alcohol. Okay, from the alcohol. And he said is a beta elimination. We said beta elimination. Why? Because we remove the OH and the hydrogen from the beta carbon. We said beta reaction in which the element of the hydroxyl group, the OH and the hydrogen, are removed from alpha beta carbon. Okay, I said before. Some books they write 1,2 dehydration. Okay, and you can write beta dehydration. Okay, the same thing. And to give you a new bond here. Okay, H2O raka double bond dana. Okay, now general feature for the dehydration. طبعا, of course, by acid cannot be happened like that. Look, not base. That meaning if I give you kuhol, not alkyl halide, and give you alkene, and I said you write the reagent, you have to write acid, not base. Okay, acid used to dehydration for alcohol. but the base used to elimination for alkyl halide. Okay, here the different. Here the different. Also, this reagent is a para-toluene sulfonic acid. The TSOH is also this strong acid, talaba. Okay, this is the structure, and is strong acid. We can write it like TSOH, toluene sulfonyl acid. This is the toluene sulfonyl acid, and you can use also H2SO4 or maybe HCl. Okay, to give you alkene. And also the same thing, more substituted alcohol, more substituted alcohol, more readily, okay, dehydrate more readily. That meaning it will be easy to enter the elimination reaction, give rise to for the lowering factor of reactivity. It will be tertiary alcohol, it will be faster than secondary, and secondary faster than a primary alcohol. طبعا the mechanism here, where is the mechanism? Okay, I will take it here, the mechanism. But look here, the more substituted alkene is the major product. Okay, the same thing for the elimination, the Zazel rule. Okay, if you have more than one type of the beta hydrogen, look, this beta carbon, this and this also beta carbon, this like this, it will be B1, beta carbon 1. This is beta carbon 2. That meaning if the acid and the elimination happened here, it will be give you more substituted alkene here, the more substituted alkene. If the elimination happened here, it will be give you less substituted alkene. Anyone is the major one. Of course, the tri-substituted alkene is the major one because it will be more stable for the double bond. Okay, the same thing. And look here, the mechanism of dehydration depends on what? On the structure of the alcohol. Okay, secondary tertiary alcohol react by E1 elimination. Okay, why? Because the stability of the carbocation, whereas the primary alcohol react by E2 mechanism. Also, I will give you the explanation for the E1 and E2 mechanism for the dehydration of alcohol. Now, he said, look to the mechanism. Dehydration of secondary and tertiary alcohol. By what? By E1 mechanism. Okay, by E1 mechanism. Look, we have this alcohol, okay, and we have this acid. This, the OH group is can be do as a nucleophile or as a base. Why? Because we have unshape of electron. This unshape of electron attack the proton of the acid. Why acid this? Because a proton donor. And it will be give you proton. Okay, proton donor. That meaning the OH, it will be take a proton from the acid and give you OH by 2 positive. OH2 positive. And now OH2 positive, good leaving group or poor leaving group? Of course, good leaving group. Okay, good leaving group. And it will be leave the structure and give you carbocation. Look, the step number 1, the step number 2 give you carbocation. Carbocation is stable? Yes, stable. Why? Because it's tertiary carbocation. Okay. For this reason, we say dehydration of secondary and tertiary alcohol by E1 mechanism. Okay, why? Because secondary or tertiary alcohol give you stable carbocation. A primary alcohol طلبة don't give you stable carbocation. It will be give you primary carbocation, not stable. That meaning for the secondary or tertiary alcohol, it will be by E1 mechanism. For primary alcohol, it will be by E2 mechanism. Why? Depending on the stability of the carbocation. Okay, focus on this. And this the leaving group. Now you have the base here. The base, it will be coming from the acid. We have the negative part. This is the negative part. Okay, this is the negative part. Okay, that meaning the base, it will be attack the beta hydrogen and make a new bond. Okay, give you elimination of product, give you the alkene. Okay, give you the alkene. But for the E2 mechanism, look, for the primary alcohol, give you E2 mechanism. Okay, why? Because it is cannot be happened by E1 mechanism because the stability of carbocation. Now, what is the E2 mechanism? Also one-step mechanism. The first one is the unship of electron, take a proton from the acid, give you OH2, good leaving group. This is a proton transfer. طلبة أو خطوات بيجن protonation. Protonation يعني added the proton to the hydroxyl group. Protonation of the oxygen of the hydroxyl group. Protonation. Also we said here protonation. Look, this step is a protonation. Okay, protonation يعني added the proton. Okay, add the proton or take a proton from the acid.
بس وكي كحول تدي في خطوة شيء
وكي كحول
وكي او اتش تدي
أو كحولة.
يعني هنجي دي بروتونيشن شيء
أوجي ما أنا هكا تكحولها يا خطوة أولي بروتونيشن هردو كذا سيم.
درست.
يعني E1 طلبة E1 و E2 dehydration of الكحول خطوة أولي بالضبط خطوة أولي ذا سيم لوك أو خطوة بروتونيشن أو جين بروتونيشن. Okay, there is no different. Where is the different? اختلاف الكيفي اختلاف خطوة دوية. Okay, very دو خطوة هيا دو سي خطوة دوية كاربوكيشن وخطوة سي make a new bond.
حسيت ممكن يعني.
E2 mechanism no just two step.
إيك خطوة.
إيك خطوة. Okay, إيك خطوة. أبا إيك خطوة. That meaning the nucleophile here or the negative part or the it will be the unship of electron for this for this part it will be attack the proton for the beta from the beta carbon and give you double bond and this it will be removed. يعني طلب E2 mechanism it is like SN2 هيك خطوة. اوكي هيك خطوة بس خطوة أولي بروتونيشن أو بروتونيشن تحسبنا كميكانيزم چونكو just acid base reaction طلب أو acid base reaction أما بيسة أبا acid base reaction أو ميكانيزم. اوكي نعم يعني بنفيسنفيري طلبة if you have a pen بنفيسنفيري acid base reaction هاو خطوة أولي ما بين دو قوس acid base reaction. Okay, look to the base, attack the proton from the beta carbon, make for you a new bond here and this it will be go out. يعني طلبة صح كيف we have a negative charge here, it will be make a new bond with the proton and the hydrogen carbon it will be broken, make double bond. Carbon carbon double bond here it will be formed. Carbon oxygen here it will be broken out and it will be leave the leaving group. Okay, it is just SN2. Okay, we have two new bond, this a new bond and this a new bond and two bond it will be broken. Okay, and here two bond, look, two bond are broken and two bond are formed in single step, just one step. A1 again, A1 carbocation formation, here we don't have carbocation. Okay, E2 there is no carbocation, E1 there is carbocation. Look, this E1 we have carbocation. Okay, but E2 we don't have carbocation, there is no carbocation. Oh, for this reason it will be suitable for primary alcohol. Okay, primary alcohol. Primary alcohol cannot be give you a stable carbocation. It will be go by E2 mechanism. By E2 mechanism. And he said carbocation rearrangement. He said طبعا أو بعالمها ويجنر Marwin rearrangement. He said rearrangement can be happen for the carbocation. How the rearrangement it will be happen for the carbocation? it will be happened rearrangement from the primary to the secondary, from the secondary to the tertiary, يعني from the weak carbocation to the more stable carbocation. I will explain for you how it will be happened. And look to the here, we have this reaction, yes? He said if you have this reaction, this كحول, and you said this كحول, it will be go by any mechanism, secondary alcohol, that meaning it will be go by E1 mechanism. E1 mechanism said we have protonation here and give you carbocation, okay? And we have a new double bond, all here, okay? That meaning if you have, that meaning it will be give you a new product, this or this. And the major one and the minor one, okay? And he said any major, anyone it will be major, anyone it will be minor. This it will be the major 1, 2, 3, 4, and this it will be minor because this tri substitute and this di substitute. And this is the best one. Okay. Now he said this stable carbocation can arrange to more stable carbocation by what? By shift of the hydrogen atom or alkyl group. Look, of the hydrogen atom or alkyl group. I will explain for you. No, look, how the alkyl group it will be shared. Here, if you have here carbocation, this R group or the hydrogen with both of the electron, hard electron, it will be removed to the carbon behind for the original carbon. It will be 1-2 shift. يعني تدو كربون هيا جيرانتكن أو جيرانتكن it will be 1-2 shift 1-2 okay 1-2 shift, that meaning it will be shift, it will be move from one to the other. Why? To give you more stable carbocation. I will explain for you how it will be happen. He said movement of the hydrogen atom is called 1-2 hydrate shift, okay? It will be 1-2 hydrate shift. If we remove the hydrogen atom طلبة, it will be 1-2 hydrate shift. If we alkyl group, it will be 1-2 alkyl shift, okay? 1-2 hydrogen shift, 1-2 alkyl shift. Look to this. Now, look, this any carbocation, primary, secondary, or tertiary, of course it will be secondary. Why? Because we have two alkyl group, this alkyl group and this alkyl group. Okay, it will be secondary carbocation. Now, if we make 1-2 hydride shift or 1-2 hydride shift, ava bina very positive they had very it will be tertiary carbocation. Now, anyone is more stable, secondary or tertiary carbocation. That meaning rearrangement it will be happened. Okay, why? To give you more stable carbocation. That meaning rearrangement it will be happened. Now, this compound, طلبة, this compound is already tertiary carbocation. This tertiary carbocation. That meaning it does not need to rearrangement. Okay, دعيناكت يعني rearrangement دعيناكت يعني خلاص there is no rearrangement خلاص أو tertiary. Okay, tertiary يعني أو قلق مستقرة. Tertiary carbocation مستقرة. Okay, that meaning primary rearrangement can be happen to the secondary. Secondary rearrangement can be happen to the tertiary. Okay, but tertiary, no, there is no rearrangement. Here, 1-2 shift, طلبة, 1-2 shift. He said here 1-2 shift, يعني 1-2 hydride shift or 1-2 alkyl shift. Okay, is convert the less stable carbocation to more stable carbocation. Okay, do you understand this, طلبة? How the hydride shift or 1-2 the alkyl shift for the rearrangement of the carbocation. Be careful. Okay, I want from you to write this, طلبة, write this, and I want to write the product. Okay, to write out the product and to think about how the mechanism will be happen. And then look to this explanation. We have 1-2 and we have 1-2 shift, يعني 1-2 hydride shift or 1-2 alkyl shift. Again, this is important, طلبة. And look to the mechanism, the same thing. Okay, the same thing. We have secondary alcohol. Secondary alcohol, that meaning is stable for the E1 mechanism. Okay, E1 mechanism. And look, the first one is a protonation. Yes, protonation. Remove the leaving group, it will be give you carbocation. This secondary carbocation. احتمال هي دي بدنا tertiary carbocation. احتمال هي يلا I'm checking. Okay, this remove this alkyl group from here to here give you what? Give you tertiary carbocation. يعني طلب rearrangement هي. Okay, that meaning rearrangement can be happened here and convert from the secondary carbocation to the tertiary carbocation by 1,2 alkyl shift. Okay, by 1,2 alkyl shift, and then make the other the final step is for the E1 mechanism. The negative here, the negative part from the acid, it will be take the proton on the beta carbon to make for new bond here, and maybe it will be take the proton here to make a new bond here. Anyone is the major one? Of course, this is the major one because is this high substituted alkene. Okay, high substituted alkene. This is the main one. يعني do product هي. إكشوان high percentage, إكشوان low percentage. نسبة عالية, نسبة قليلة. And this homework for you, I think also this resolve homework actually. Not homework. Show how dehydration of alcohol. طلبة alcohol وacid هي خلاص dehydration. Okay, it will be and he said here 1,2 hydration shift it will be happened. Yes. Protonation or protonation. Carbocation. Now carbocation we have rearrangement here. This secondary carbocation. Okay, maybe it will be tertiary carbocation. How? By 1,2 hydration shift. Look, 1 to this, it will be come to here and give you positive charge, and then the negative charge here or the base, it will be attack the beta carbon to give you the double bond here. That meaning the product is this. Okay, the product is this. Okay, if you look to here without rearrangement, if you make to write the product without rearrangement, you say the double bond will be here or here, but actually no, not here or not here. The double bond it will be happen here. Okay, and he said with this homework, introduction to this homework, show how 1,2 shift form more stable carbocation from each intermediate. Okay, now you have this carbocation, this secondary carbocation, how it will be tertiary, this secondary, how it will be tertiary, this secondary, how it will be tertiary. That means طلبة, I want to write the tertiary carbocation from this, write tertiary carbocation from this, write tertiary carbocation from this. Okay, use 1,2 shift to show how the carbocation it will be rearrangement. The second one, explain how the reaction of this with H2O yield to substitution product. Okay, this and this. He said that meaning this compound give you two products, this and this. How it will be happen? Also, this homework for you. Just write the reaction, all the reaction. Okay, you have here the nucleophile is the H2O, and you here alkyl halide. Okay, this is alkyl halide. That meaning we have here substitution طلبة, substitution reaction, substitution reaction. Focus on the substitution reaction. طلبة, introduction to the acid addition reaction. I will stop here to the introduction of the addition reaction. I inshallah will take that next lecture. Also, you have exam, I think, with Dr. Suhad. Then I